Alright, welcome everyone. Let's continue with lesson number 2, part 1. What's the game plan? We will be multiplying polynomials. So the idea is we're going to be learning this box method for multiplying polynomials. Let's take a look at the first example. Here, Gisela computed 342 times 23 as follows. So this was her work. Can you explain what she is doing? What is her final answer? So the idea here is just take a minute and pause the video, try and see what Gisela was doing. Yeah? Okay. So here, if you unpaused, what was she doing? What's the relationship with this 2 into 20? 2 times 20 is 40. 40 times 20 is 800. 300 times 20 is 6,000. 2 times 3 is 6. 40 times 3 is 120. 300 times 3 is 900. And then what did she do with all these values? She's just going to add everything up, and her final answer should be, this is what, 6,000 plus this is 7,700, right? Plus the 160, so that is 7,860, and then 7,866. That should be her final answer, yeah? Okay, so take a second and try and explain in your own words what she is doing, yeah? So how does this work with polynomials? Over here, if we have this this polynomial over here of 3x squared plus 4x plus 2 times this 2x plus 3, how do we take this polynomial and multiply it to this one? So let me zoom in a little bit, and the idea is I'm going to show you how to use this box method to multiply this polynomial, okay? So let's take a look here. Before we actually go into the box method, how do we create our boxes? I remember I showed this last year and it helped a lot of students. When we create boxes, and I want you to be patient before we actually get into this, but here, notice that how would you draw a 1 by 1 box? It'll just be like this. How do you draw a 2 by 1 box? Notice that this is the first box, yeah? And then we're gonna go here, the left side over here, this is talking about the horizontal, and here this is talking about, this is talking about the vertical, and here this is talking about the horizontal. So if I have 2 by 1, it will look like this. What would 3 by 1 look like? It would look like this. Yeah, so I have 3 boxes here. Let's try again with this over here. This is a 1 by 1. This is 1 by 2. This is 1 by 3. Yeah? What I want you to do is try and create the next following boxes. What do you think a 2 by 2 would look like? You know, pause the video and try and do this on your own. Here, with a 2 by 2 box, something like this, yeah? 3 by 2 box, notice first we're gonna have to go 3 like this, and then yeah, this is a 3 by 2 box. So notice how it'll look something like this. A 2 by 3 will look something like this. Okay, it doesn't have to be too perfect, but that's the general idea of making boxes. So notice here, what kind of box are we gonna create over here? We're gonna make a 3 by 2 box. Okay, and what I want you to do is pause the video and try and create a 3 by 2 box. Okay, and let's say if you unpaused, let's actually try and do this problem. You could do it on this paper or a separate piece of paper. What I did was I created something just like this, and what we're going to do is we're going to show 2 different ways of multiplying polynomials. So the first way will be through the box method, and here the actual classical way is through the distributive method. So let's take a look over here. What is the game plan for this? Let me move this, let me have that. So here what we're going to do is we're going to take this polynomial and just put it over here. So we have 3x squared plus 4x plus 2. And then here we're going to have this polynomial and we're going to bring it right down here, 2x, and we're going to do a plus 3. And try and be consistent with your signs. And the same way Gisela was multiplying her 3 by 2 operation over here, we're going to be doing that with this. So here, the game plan, what is 2 times 2x? We'll have that over here. But just a real quick essential notes that we should have for this lesson, what I want you to do is pause the video and copy this. Last lesson we talked about adding and subtracting polynomials, right? Or adding and subtracting like terms. What was essential within that lesson is that when we add and subtract these terms, we keep the exponent, right? So this would be what? 5x squared plus 3x squared. It is not 8x to the 4th, yeah? It is 8x squared, okay? But when we're multiplying terms, we have to add the exponent. Okay, so this is very crucial. So notice that here we do 5 times 3, 15, and this x squared times x squared over here, this becomes x to the 4th. Yeah, we're just going to add the exponent. So this is really nice to have in your notes. Okay. Now going into this, so we're solid with the principles of multiplying here. 2x times 2, 4x. Then how do you try and do this on your own? Like, try and follow that rhythm. 2 times 2x is 4x. 4x times 2x. What is 4x times 2x? This is 8x squared. Because notice that what is the exponent over here? There's that invisible 1, right? And we have 1 plus 1, which gives us that 2 for 8x squared. Okay. What about this one? If I have 3x squared times 2x, so if I have 3x squared times 2x, this becomes 3 times 2 is 6. X squared times x, notice there's that invisible 1, so we have that 2 plus 1. We have 6x cubed over here. Okay? Try and do the rest by yourself, right? Pause the video and try and do it. 2 times 3 is 6. 4x times 3, 12x. 3x squared times 3 is 9x squared, right? So like if I have 3x squared times 3, notice this doesn't have anything, right? Technically there's an x to the 0 here, but we'll ignore that for now. But this should just be 9x squared. Okay, awesome. So once we have all of this, what did Gisela do last time? She just added these values over here. Once we have all these numbers all lined up, all we need to do is just combine these terms. So notice, always start with the highest exponent and then we'll go to our constant, right? So here, when we look at this 6x to the 3rd, can we combine this 6x to the 3rd with any one of these terms? No, because there is no other term that has an x to the 3. So notice we just have 6x cubed, okay? And then we're done with this. This 8x squared, can we combine with anything? Yes, we can combine the 8x squared and the 9x squared, and this becomes 17x squared. Yeah, we keep, because right now, what are we doing? We went from multiplying, now we're adding and subtracting where we keep the base. So this is 17x squared. So we're done with this and this. 4x and 12x is 16x, and this is 6 over here. And then that's it. When we multiply this polynomial with 3 terms, with this polynomial with 2 terms, we have our final polynomial here. And how many terms are there? 4 terms. Okay, so this box method is really nice to keep us like organized. Yeah, let's try and do the same problem, but we're going to be using a distributive method. The idea for this is, what you need to do is you need to take this 3x squared and multiply it to each one of these. Yeah, now this is the idea. We're going to multiply this 3x squared to the 2x plus 3, the 4x to the 2x plus 3, the 2 to the 2x plus 3. So when I'm doing 3x squared to the 2x and to the 3, visually what I'm doing is, algebraically what I'm doing is I'm just taking 3x squared times 2x plus 3. What would be the next one? I have to take this 4x and multiply it to the 2x plus 3, yeah? So then it'll look like this. So 4x times 2x plus 3. Try and envision what would be the next line, right? I'm going to take this 2 and I'm going to multiply it to this and to this. So now here I have 2 times 2x plus 3. What I want you to do is try and do this calculation yourself, right? What is 3x squared times this 2x over here? This becomes what? This is 6x cubed, right? What's the next one? 3x squared times this over here. This is 9x squared. Then what happens for this one? 4x times 2x is 8x squared. 4x times 3 is 12x. 2 times 2x is 4x. 2 times 3 is 6. And notice that we generally just got the same exact things that we got using the box method. Like these values, this 6x cubed is here, the 9x squared is here, the 8x squared, the 12x, the 4x, and the 6. Here, it doesn't matter which method you use, you're still going to get the same values that you're going to have to combine, right? So like, again, like this combines with what? Nothing. So I just have this. And then we already said we have to combine these two, so it's this. Combine these two is this, and this over here. And notice we have the same solution, right? We just did it in 2 different ways. The box method is really nice because it keeps you like organized, okay? And here, this is just the more classical way of looking at how you have to distribute this term to each one of this and so on, okay? What I'd like you to do is try and do the next question by yourself. This 2x squared, this 2x squared plus 10x plus 1 times this x squared plus x plus 1. Try and solve this using both ways, right? Try and do it using the box method, try and do it using the distributive method. And in the next video, I'll show what the solution is. Okay, I hope this helped. I'll see you.